First of all, thank you to AEC Magazine and Martin Day for inviting me to talk to you all today as part of this virtual event. Don't let my green screen backdrop fool you. I'm huddled in a small, cramped home office like I'm sure many of you are. Now, the initial subject I was asked to talk to you about was related to the future of design tools. These days, it's kind of hard to think about what the future will hold. Like many of your companies, my small digital design agency, Proving Ground, has been navigating the ebbs and flows of today's world of a global pandemic, social unrest, and natural calamity. I can't help but feel that the discourse of digital design tools is experiencing a kind of dissonance with this reality, when the more prosaic struggles of leveraging even the most basic of tools to realize a great built environment continues to persist. Among other things, it occurs to me that the global pandemic has driven businesses to finally and seriously consider their digital transformation strategy, possibly for the first time. As designers moved into their home offices, this crisis has also put more onus on professionals of all types to be more self-sufficient with their technology. As such, the relative ease and difficulty of our digital processes with our tools has come to the forefront in ways that may have been taken for granted before. Even today in 2020, computers are not exactly easy. I'm still often helping my parents figure out some manner of why won't this print, and can you help me open this file? Extrapolate that out to the context of AEC companies moving their staff to home offices combined with some of the most complicated building design software out there, and you can imagine what our IT and DT departments are juggling with in their own businesses. Speaking of AEC tools, it occurs to me that it has been over 18 years since Autodesk acquired Revit Technology Corporation. The promises of BIM to transform building design and construction over these years have been numerous. Among these promises have included the integration of disciplines resulting in fewer coordination issues on site, the use of data-rich objects expediting quantity reporting and takeoffs, and the reliance of 3D objects making 2D documentation theoretically obsolete. Moreover, the informational aspect of BIM showed promise and the opportunity to leverage data for informed feedback loops in design. And yet, a visit to digital design conferences and executive meetings in leading design companies today revealed continued discussions about bridging skills gaps, dealing with low levels of standardization, managing poor data quality, and navigating labyrinthine project workflows to move information among team members. Meanwhile, the 2D document product continues to rule the day as the primary means of assigning professional liability and coordinating architecture. Now, this shouldn't imply that the problems of realizing the potential for data-rich transformative workflows is associated with bad software, although there is much to critique about the AEC industry's core platforms. Instead, I will posit that we exist in a space full of wicked problems that technology alone is unable to solve, and that perhaps the future of design and the tools we use to perform design has less to do with fanciful algorithms with the ability to produce a deluge of information. Perhaps it has less to do with the novel implementation of artificial intelligence that approximate, at best, caricatures of design processes. And perhaps it even has less to do with how much computational power we can put into the cloud, and that allows some to collect the bounty of recurring revenue. Maybe when we go into the core problems that affect the quality of design, those prevalent in conversations at conferences and business meetings, the answer comes from revisiting fundamentals. In the last 5 years of establishing Proving Ground as a consulting practice, I have been fortunate enough to work with and among a wide array of clients. These organizations span leaders in design, engineering, construction, and facility owners. In my estimation, the famous quote by William Gibson holds true. The future is already here, it's just not evenly distributed. Firms are floating in a sea of all manner of technology and data, but are also failing to swim due to numerous skills gaps that fail to get bridged due to relentless project cycles and being swamped with all manner of other responsibilities for delivering some of the most complex assemblies out there. Buildings. We see the championing of learning to code among professionals that struggle with basic computational concepts, or let's make a dashboard for managers who may lack basic data management capabilities in Excel, or a call to be data-driven when architecture, education, and practice lack emphasis in practical analytical concepts, to say nothing of little or no direct experiences with database fundamentals. But we have seen success. When digital strategies move beyond fetishization of height-driven advanced topics and instead look at how to equip designers and managers with skills that address core problems. When tools are positioned to lower the barrier to entry for complex processes, and when there's a recognition among leaders that the reasoning of, because this is the way we've always done it, is not a valued argument to support wasteful, time-consuming processes. Let's look at some examples. There can be little doubt that digital workflows today are full of friction. Data gets stuck in silos of various authoring platforms, models have to be rebuilt, and data needs to be manually re-entered. However, workflow design has come into fashion with some leading practices looking to streamline wasteful processes, and CAD vendors such as McNeil have placed emphasis on new modes of compatibility in their design tools. Yet many of these solutions often fail to scale to a broad user base. Computational design knowledge, represented by Grasshopper and Dynamo, is still not commonplace among a broad base of users, even after over 12 years since Grasshopper hit the scene. As such, many larger practices retain software developers and computational specialists just to get the tools to interoperate. As consultants, we have acted as those specialists for many projects, including the Hangzhou Stadium by MBBJ, the Lucas Museum of Narrative Art by MAD with Stantec, and the American Museum of Natural History Gilder Center by Studio Gang. 10 years ago, I published a peer-reviewed research paper on workflow friction present in projects like the MBBJ Stadium and highlighted the spaghetti of disintegrated processes, file formats, and information barriers. Over the years, in building up a core set of tools through various project engagements, we have recently published Conveyor, a commercial plugin that aims to provide a general purpose set of translation workflows for any skill level in a common problem space. How can I translate my data and geometry from Rhino to Revit? I believe that if a user knows how to perform standard modeling operations in tools like Rhino or Revit, then moving geometry between them shouldn't require computational design knowledge, coding chops, or advanced data management skills. Conveyor leverages the fact that McNeil has created an open file format with open NURBS, and it has been available for years. This enables Conveyor to read geometric data right out of the file so we can reconstruct the data using ready-made automated processes and a conventional user interface. Floors are remade direct from Rhino surfaces, Rhino blocks are constructed as Revit families, and complex meshes can be represented as clean geometry for documentation. There are many solutions out there in the wild for this, but in combination with an emphasis on situating the technology for broader usability among designers, we can observe these workflows having a wider impact. However, that does not let software vendors off the hook. As consumers of technology, we need to continue to hold our software providers accountable by demanding open workflows and more pathways for data compatibility so that we can continue to build integrations that work for everyone. And data integration is central here. The future of design points us to AI as a concept that can help support design decision-making based on data. Yet it is evident that even the most basic of data integration in early design tools is lacking. A walkthrough of mainstream design practices still shows planners and designers performing manual area takeoffs on surfaces, aggregating the data in Excel, or even tabulating totals with a calculator. That seems odd in the wake of sophisticated building information modeling frameworks. Recently, we released a new plugin for Rhino called Semantic. The premise is simple. We wanted a utility for flexibly integrating data with conceptual Rhino geometry and a system for automatic reporting of those attributes as the design progressed. That sounds super basic, but it is still a barrier for many. Semantic exposes a new UI allowing for data property management and a live report feature. As designers scale, trim, add, and subtract geometry, the tool reports on the status of the design properties. We have taken the workflow further by allowing users to export their properties to common data formats and read the Rhino model directly into business intelligence software that is growing in popularity. Power BI, a Microsoft dashboarding and reporting tool, is finding its way onto the desktops of many building professionals. It allows users to combine data sources and create interactive dashboards with charts, tables, and publish them to the web for sharing. All of this is possible without the need for coding or web development know-how. With Semantic, we latched onto this workflow and created a way for designers to view their Rhino designs in an interactive dashboard, combine it with other data, and create data-rich presentations in a matter of minutes and without the need to write a single line of code. This does not get the designer off the hook for needing to understand data presentation and analytical fundamentals, a central tenet for any successful implementation. However, the goal here is to lower that barrier to entry for data-driven technology and equip a broader group of users to engage in ways they have not been able to previously. As designers get more comfortable with data, there are a few inevitable questions I often get about the workflow. What about all the data we have created in the past? Can we analyze it? Can we leverage it? Can we use it to improve our processes and design? Indeed, if BIM has enabled anything, it is the opportunity to leverage common data structures for building geometry and data relationships. A Revit file is a database, as are other non-proprietary formats such as IFC. Of course, while the data quality of these files is sometimes questionable, the common data structures of BIM provide an opportunity to understand our data and determine different courses of action. Tracer, our Revit data analysis toolkit, provides a mechanism for harvesting Revit data into a standalone relational database. In combination with Power BI, we can visualize the underlying data of any Revit model and even produce automatic and dynamic architectural diagrams directly from Revit elements. Using this data, a team can build up all sorts of analytical reports that can help set courses of action. A course of action may even come in the form of a quality analysis of the data itself and help teams establish quality control procedures for auditing and evaluating the building information model. Actions may also result in the form of orchestrating a dashboard that uses BIM with owner-facing metrics for space utilization and other concepts that can impact the design of a facility. The examples I have described here today are not exactly out there or radical. I didn't touch on generative frameworks that are so popular in today's marketing presentations. I didn't discuss our research with machine learning or the Internet of Things, and all of these ideas are certainly important. Instead, I wanted to address more prosaic concerns in design with an aim at bridging skills gaps so often present in design and construction practice. There can be little doubt that there is a clear need to push data-driven design. Construction waste is projected to double globally by 2025. Buildings are a leading contributor to greenhouse gas emissions, and growing populations are requiring us to think about how we are building our cities to meet demand. We need evidence-based workflows, processes, and tools to become commonplace in our businesses, and we need to mobilize our people to take advantage of them. This, in my view, is the future of design tools and the path forward for a data-driven agenda for architecture.